We saw that Newton's completely transformed physics by giving three fundamental laws of motion, which we previously discussed in chapter 3. Before going to Newton's gravitational law, let's recall gravity and gravitational force. So what is gravitational force? Basically, gravitational force or gravity pulls the objects towards the center of the earth, which causes gravitational acceleration g according to Newton's second law. G is gravitational acceleration towards the earth for freely falling objects. For example, the case of an apple that hit the head of Newton. Newton called this pulling force a gravitational force. If objects apply force on each other, then it would accelerate towards each other according to Newton's second law of motion. It is defined as F is equal to ma. From this relation, we get A is equal to F divided by m. And here is inverse relation between acceleration and mass of the object. So, higher the mass, lower will be the acceleration. In the case of apple, mass is very small, so it would accelerate it greatly towards the earth. That's why apple accelerates towards the earth and earth does not. So what is Newton's gravitational law? Isaac Newton was the first man who gave the idea of the gravity by observing apple falling towards the earth. Before going to the Newton's gravitational law, let's take an example of two bodies having mass m1 and m2 and separated by distance r. Both exert force on each other. Now, let's define Newton's gravitational law. Every body in the universe attracts every other body with a force which is directly proportional to product of their masses and inversely proportional to square of the distance between them. Mathematically, we can write as F is proportional to m1, m2, and F is inversely proportional to r square, which means F is proportional to 1 over r square. By combining both relations, we get F is proportional to m1 multiplied by m2 divided by r squared. From this relation, we can conclude that mass is higher, then force will also higher. But if the distance is increased, then force will decrease. By removing the proportionality symbol, we can get F is equal to G m1 m2 divided by r square. Here G is the proportionality constant called gravitational constant. This gravitational constant is also called universal gravitational constant because its value remains same everywhere in the universe. From the previous formula, we can represent G as F multiplied by R squared divided by M1, M2. Its value is very small, which is equal to 6.673 multiplied by 10 raised to the power minus 1 Newton meter square per kg square. Units is from this formula, Newton from force, meter from R square, and kg square from their product of their masses.